Welcome you all for this session on Introduction to IoT Security. And I'm Anand. So I'll be the presenter of the session on the topic Introduction to IoT Security. So before kickstarting into the presentation which I have for you, I would like to extend my gratitude to both MedTechSecure and the hacktivists for inviting me for this session. And like it is nice to get connected with you guys in this platform. And so before kickstarting into the session, like I'll just give a brief introduction about myself. So as I mentioned, my name is Anand, and I'm currently working as a product security engineer for Philips. And I have around 3 years of experience in the information security domain, which involves penetration testing of hardware and application security. And yeah, in my current role, I generally get involved in the red teaming activities of various products of Philips. And yeah, that's just regarding my technical background. And regarding my education, I completed my master's in cybersecurity systems and networks. And yeah, that's just a brief about myself. And like further this session, if you guys want to get connected on anything regarding this topic, you can feel free to reach out me on the LinkedIn handle where the link is provided. So getting into the uh, session. So this is the agenda for the session. That is, as the title hints, this session is for like an introductory section on the IoT security or the hardware security. So this is basically for people, those who wish to get kickstart in the hardware security domain, or people those are also already have that exposure. So this will be like a basic introductory session where we can get hands like get to know some basic details regarding what all are the basics of hardware or IoT security when we test something from a penetration tester's point of view. So here we have splitted this session into different uh, topics, so which is been like mainly split into the hardware components. We'll be discussing about some of the major hardware components, which will be followed by some protocols used in hardware. And also we'll be looking into the attack surface, where all the attack or the security vulnerabilities can occur in an IoT or hardware system. And also we'll be looking at the security assessment flow, like from a penetration tester's point of view, how we'll be approaching, what will be our approach to find out the issues or vulnerabilities in a hardware device. And also at the end, we'll be looking at some of the most common vulnerabilities which we come across in our penetration testing. And at the end, we'll be looking at some of the demonstration of some of the issues which we have discussed. So first of all, since like it's a session on hardware security, like we have our own limitations, like as we know, like as we'll be aware, like hardware security or hardware something which we want to excel in hardware will really require our hands-on expertise, which like with just a verbal talk we won't be able to get the full understanding of it. But still with this limitation of this virtual environment, we'll try to cover the basics like from a theoretical point of view. So for the demo purpose also, I have attached some pictures and screenshots of some of the devices and some of the tools. So we'll be looking all those in the coming slides. So starting with the hardware security, so as the title hints, like it is something which is intended for securing the hardware peripherals or the hardware devices which we use in our day-to-day life. So like when we look at the devices what we use, generally nowadays we all are using a lot of devices which relies on IoT, mainly on IoT devices. So IoT devices is nothing but like the Internet of Things, where the devices which will transfer data or which will get connected to the internet. So in our day-to-day life itself, we'll use various kinds of IoT devices like smart watches or any other monitoring devices with sensors. So we'll be using different kinds of like hardware devices, and the security or the security perspective of those devices also very much like critical in in the recent days, because as we are moving on to a digital world and everything is getting digitalized, so our data, it can be of any kind of our personal data or any other monitoring data, if it get disclosed to an unintended person, so it will create a huge impact. So hardware security is something important which we have to focus, and it is very much critical for our day-to-day activities. And in this slide you can see a pyramid kind of structure where it has splitted the hardware components into the impact of how a security impact can be on each of the part. Like the top part is a sensor. Obviously we'll be aware like hardware or the IoT devices will have various kinds of sensors. Suppose in the smartwatch itself we can have multiple sensors for health monitoring, or it can be for uh, like a temperature sensor for getting the temperature outside. So various kinds of sensors will be used, and also there will be certain kind of communication happening, so that for that it can be using any kind of communication protocols like Bluetooth. It can be of Bluetooth communication, or it can be of Wi-Fi communication, and which is followed by other components as well, like firmware and hardware platforms as well. So when we look at the hardware from an high overview, high level architecture, this is just a high level architecture of hardware components. So we can split it into multiple categories. But in this session, we will be mainly focusing on these two parts, that is the firmware and the hardware platform. So since this is the majorly impacted components in a hardware, from the hardware security part, we'll be focusing on to the basics of these firmware and hardware platform. And regarding the components, so when we look at a hardware component, actually there can be a lot of components like within a hardware device. So we won't be looking at each and everything. So from the security perspective, we'll be mainly focusing on enormous number of components. But among that itself, here I have listed some around 5 components, which consists of some protocols as well. So these are some of the major components which we should be aware from an beginner's perspective. This without this we can't perform. Without an understanding of this, we can't perform an proper hardware pen testing on any hardware or IoT devices. So those major components are this microcontroller, followed by flash or EEPROM or EEPROM, and the other two are the protocol, that is a UART, which stands for Universal Asynchronous Receiver Transmitter, and JTAG and SWD, which is followed by USB. So we'll be looking into detail about each of these components in the coming slide. Yeah. So microcontroller. So when we take an hardware device or an IoT device, so not only from the security perspective, from that device or from the developer's perspective also, microcontroller is something which is, we can say, as a heart of the hardware or IoT device. So this is something like from like for computer we'll tell the CPU, right? So similarly for the hardware or IoT device, microcontroller will act as a brain or the core part of the hardware device. So this will be coordinating the activities happening, like the activities happening in the device, like what kind of actions or to be done, or what kind of data to be transmitted. So all those mechanism or the major function handling of the particular device will be handled by this microcontroller. And when we look at the microcontroller, there are various kinds of microcontrollers available. So here we have listed some microcontrollers with different pin outs. So here we can see like microcontrollers with 4 pin, 8, followed by 16, 32. So depending on the device, the developers can set up like what kind of microcontrollers need to be used for a device. And so based on that, like we'll also be performing our like security mechanism for like finding out, okay, what protocols or what kind of methodologies can be performed in this scenario. So once we get a device for a pen testing, obviously microcontroller is one of the component which we'll be initially looking into, and it is followed by Flash. This is another important component in a hardware or IoT device. So Flash, I think majority of us will be aware, like it's kind of non-volatile memory. So it is basically used as an internal memory for either it can like either the microcontroller might be storing some kind of code, or even a firmware also can be stored. In certain cases, it can be like stored in a flash memory. So Flash also similar to the microcontroller, it is of different pin sets. So here at the in the slide, you can see an 8-pin flash memory and then 16 pin flash memory. So similar to the microcontroller, like depending on the device, like if it is like a hardware device with minimal functionality, or it's a small device, it doesn't require a huge flash memory. Even it can go with an 8-pin flash memory. So depending on the device, we can have like higher ends of or the lower end of flash memories. So that's regarding the flash. And another component, major component, or this is actually a protocol like UART. It stands for Universal Asynchronous Receiver Transmitter. So this protocol is also one of the in hardware itself, there are various kinds of protocols. In protocols, we'll be mainly looking into three or four protocols in this session. So this UART protocol is one of the very basic protocol used in most of the hardware devices. So this is kind of a serial protocol which is used for a direct communication between two devices. So that means like in majority of the cases, the hardware device might be interconnected, like there might be communication happening from one device to the other. So those communication channel or those communication will be handled by this UART protocol. So it's like it can have mainly two sets of pin. So one is for the transmitter, and the another one is for a receiver. So just imagine like in this image, this UART one is for one device, and this is the another device UART two. So both these will have UART protocol, and it will have a transmitter, TX trans for transmitter and RX for receiver. So the transmitter will be connected to the receiver, and the receiver will be connected to the transmitter in the vice versa form. So that the communication will be happening in an kind of a serial channel. So where the two devices can interchange their communication and data through this UART protocol. So basically, this protocol is mainly intended for the connection between two devices. And another protocol which is mainly used for debugging, it is if the previous one was used for a communication for devices, and this one is mainly for uh, debugging purpose of the device. So here for the debugging, generally we can have two protocol. One is JTAG and another one is SWD. So both these are debugging protocol with some differences. Like JTAG actually it is intended for like high-end protocols, like high-end devices. Like suppose for easy understanding, we can say like you can see this diagram in this image in this slide, where there are multiple points being marked. So here you can see some points with TMS, TCK, TDO, TDI, the one starting with T. So these four pins are for this from JTAG, and this one starting with SWD is of SWD protocol. So that is like this JTAG is been generally used in high-end devices which requires multiple used to handle huge functionality or used to handle huge data, where it requires multiple pinouts. So it will have a TDI stands for data in, input and DO for output. This is nothing but similar to what we saw in the UART. Like in those cases, only 2 points were there, one receiver and transmitter. But when it's for a debugging purpose, it might not be possible, especially for a high-end device, to incorporate or handle those data through a single pinout. So for the JTAG protocol, we have to, it will have mainly this TDI and TDO are separate, that is input separate and output separately, and CK is clock. And so this everything will have a clock and a ground. Like from the hardware perspective, if we want to test something, we need to find out the voltage, ground, and clock. So voltage is the one which is mentioned as VCC, and ground is GND. So that will be looking further in the further slide. So just for this protocol, you can understand like JTAG is mainly used for high-end devices, and SWD is for uh, small devices with limited functionality. So why we say as it is for small devices? Because in the case of JTAG, if we are using separate input and output ports, but in the case of SWD, here you can see it's a single point where SWD IO, the both the input and output communication will be happening through a single channel or a single point. And so in this case, since it is happening through a single channel, handling of huge volume of data or using it in a high-end device might not be applicable in this case. So like even though this much protocols are there, it's up to the developer of the particular device to set up like what kind of protocols need to be set for those devices. So suppose I'm intending to use or develop an huge healthcare device. Obviously the usage of SWD port in that is very much limited because it cannot handle huge volume of data. So in those case, we'll go with the JTAG, where we'll have separate pinouts for each input and output. So this is just an overview, like of just for making you understand like what's the major difference between JTAG and SWD, which is the debugging, one of the common debugging interface like protocols used in the IoT devices. And another protocol which we generally C is I2C protocol, that is inter-integrated circuit. So this one, it's a kind of we can say it's kind of communication protocol. But what makes it interesting is like it can even be used in a small end device to a high end device. So it have those flexibility where it can have in this image there is only one master and multiple slaves. But actually in I2C protocol, it's not necessary like it should have only single master. It can have even multiple masters with multiple slaves, or single master with a single slave. So that flexibility factor is here. And from this perspective, the points which we generally have is SEL and SDA. So the so through this serial channel, the communication will be happening. So this is also, these are some of the common protocols which we come across in most of the IoT devices. And just for your reference and just for an easy understanding, I have listed out the major points what we discussed. Like as I told, in JTAG protocol, we mainly look into TDI, TDO, TMS, and TCK points. So suppose just imagine like I got a device and we have to analyze that device. So for understanding that, if suppose if it is using a JTAG interface, we have to find out these 4 points in that particular device for finding out what communication is happening in that protocol. And suppose if it is using I2C, we have to find out SDA or SCK. And for the SWD protocol, SWIO and SW clock needs to be found out. And for the UART, as we looked initially, like it will have to find out the transmitter and the receiver points. And these are the testing points for these protocols. And along with this, as I mentioned earlier, like ground and voltage is mandatory. Like it is a kind of default for all these protocol. Despite of what the protocol it's been used, we need to find out the ground and voltage. So this is regarding the testing points of various testing points of the protocols that's been used in most of the common ones in the IoT devices. And Another component which we majorly come across is the USB, which might be very much familiar to all. That is a universal serial bus. So it's the same one what we come across in our day-to-day life. So majorly for if it is like a high-end device or if it is a healthcare device, so generally it will have certain USB points where it can be used for some external storage, or sometimes for connecting external devices to that particular device will be having USB points. So suppose like those points I have USB, I have mentioned it as an important component in the IoT security, because suppose just imagine like there is no proper validation or security check is being done on this USB part. An attacker can try to like inject any malicious device with a USB device to the our target device, and it can take down that device and it can create some kind of manipulation. So USB is also one of the major component of hardware from the IoT security's perspective. So those were some of the common and very basic components which we should be aware aware about the IoT devices or the IoT device security. And next we are moving on to the attack surface. So before heading into attack surface, I would like to check with you whether like whether the concept of this testing points and those protocols is comfortable or understandable for you, or do you have any confusion in that? Okay, I'm taking that as no. Okay. So if even if you have any further doubts coming up, we have a Q&A at the end, so we'll discuss over there also, no issues. So the next part is the attack surface. So now we have a basic understanding of what all are the components which we will be mainly focusing on from the security perspective. So that also we can split into three categories mainly. This is actually a high level architectural overview. So mainly we can split into storage, hardware communication interface, and network communication interface. So for the storage part, we have already discussed about the flash, EEPROM, and the USB or SD card. So those are the kind of like flash and EEPROM, it will be inbuilt in the device if it is being used, and USB or SD card, it can act as kind of an external storage or external memory which is been attached to the hardware device. So this is one attack surface. Like storage of the hardware device is one attack surface, and another one is the hardware communication interface. That is what we discussed regarding the protocol like I2C, SPI. Actually SPI we haven't discussed, we didn't had a slide, but actually SPI and I2C is kind of a similar protocol, but we don't have to worry much regarding that now. But like if you know about JTAG, SWD, UART, I2C, we are good to go. So just for understanding, like these will come under the hardware communication interface, and there are another communication phase where the network communication part, like suppose if it is through a network connection, like either it will be using a Wi-Fi, BLE, or DICOM. So Wi-Fi and BLE, I think most of us will be familiar. BLE stands for Bluetooth, and Wi-Fi is the normal Wi-Fi which we get connected. And DICOM is also kind of communication interface. So people from the healthcare domain will be familiar with this. So this is kind of a network communication protocol, also network communication interface, that is being used in the healthcare industries for the communication of healthcare devices. Like we have various kinds of healthcare devices like X-ray machines or CT machines for various kinds of activities for health monitoring. So for those generally they won't be using they might be using Wi-Fi and BLE, but still DICOM is the normal standard that is being used for the network communication of the healthcare devices. So this is just a high level overview of the attack surface of an hardware device. I hope it is clear for all. So we are moving to the next part, that is the security assessment flow. So now we have an understanding of components and the device, our target device. So suppose just imagine like you have a device for the testing, for the pen testing, and what will be your approach, what should be your approach, because now we discussed about the testing points, what all protocols, but how to find out those protocols. Suppose I'm getting an medical device, keep it as an x-ray device itself. I got an x-ray device, but how do I know like what kind of protocol it is using, what kind of components it have? So in this security assessment flow, we'll be looking into how to, what is the step by step procedure for pen testing a device, or how to find out what all are the protocols and the kind of components that is being used, and after finding it out, how to test it from a security perspective for whether to check for any kind of vulnerabilities. So for that, the initial part is the information gathering phase, and it will be followed by the understanding the architecture, and that will be followed by finding the debug pods. So debug pods is nothing but we have discussed like the testing points, right? So how to find out those points, and at the end, how to perform the attack scenarios for each of these cases. So moving on to the information gathering phase. So here I have taken a router. So this is pretty much common router. So just for your understanding, I took it for our demo purpose. So just imagine like this is the device you are going to pen test. So this is the one you need to perform the security assessment. So obviously, since it is a hardware testing, we will be opening up this device and we will be looking into the circuit board and everything. So that will be our approach. But what I suggest is before heading into that, we should be there should be a kind of information gathering part before like dismantling the device. So that is like in this router we can see like the manufacturer name is mentioned, and at the back end there is some interesting data being mentioned, like it had mentioned its model name and some other kind of frequencies, SSID, and some unique IDs it's been mentioned. So this kind of data on a device is pretty much interesting. So more in majority of the cases, these data will be kind of unique, and we can get some information from open sources. So what we can do is like we can just Google it and find out what this stands for, whether there is any information regarding this device is available online. So when I have looked into it, that particular router, this is the router model number which was mentioned at the back side of that router. So when I just typed that particular model number, I got a list of links with various kinds of information. In that, this particular one, I found it pretty much interesting because in this particular one, for that particular router, there is so many interesting data it's been mentioned. Like it had mentioned it's kind of CPU that is being used. Here it's mentioned the flash chip number, what kind of flash it is using, and so many other interesting data, like yeah, it is having an USB port, and what is the type and everything. So some basic level of data we already got before even opening up the device. So that's why information gathering part is pretty much interesting, or it's pretty much like needed before heading into the circuit part. So and also in this one you have to look into is like here you can see something called as FCC ID. So FCC ID is it's a kind of standard, and it will be a kind of a unique ID for each devices. It's not necessary that all the hardware devices will have FCC ID, but suppose the device what you are going to test, if it is having an FCC ID, then it is good to have, because once we go into the FCC website, and if we give this particular ID, we'll get some more in-depth details regarding this particular device, like what kind of protocols and what kind of like network protocols that's been used. So those kind of interesting data we can get to know. So that's the information gathering part. And the next one is the understanding the architecture. So now we have opened that particular router, and here we can see a beautiful circuit board of that. So this is where our real hardware pen testing is starting. So over here, now our initial task in this understanding the architectural part is like in our components, the first component what we have discussed today is microcontroller. As I mentioned, like it is something pretty much important. So that is the initial thing what we have to find out. So from this circuit system of this router, we have found out like one flash, and this is the microcontroller. So uh, how we found out this microcontroller is like already in the information gathering part. Here we have found out like CPU, it's using MediaTek. CPU is nothing but the microcontroller. So it's and for the microcontroller part also, there is in the huge number of companies that develop microcontrollers. There are like few well-known companies like MediaTek, ARM, and STM, and so on. So mainly in 90% of the devices, it will be using either of these microcontrollers. So in this case, already here it is mentioned MediaTek and a unique number. So from this we can like understand like this is the microcontroller. And the next step for us will be like once we find the microcontroller and we got this unique ID, is to again the information gathering part. So here what we can do is like we can again go to any open source and we can give this particular unique ID of this microcontroller, and we can try to fetch out its data sheet. So data sheet is nothing but like it's a kind of it will contain various kinds of data related to that particular microcontroller. Like it will be mentioning what all points it is using. Like suppose I can show you an example. Just a second. Yeah. So this is actually, this is not the exact data sheet of that router which we are looking into. Just for your reference, I'm showing. This is another one here. It is mentioned STM32. So this is actually a data sheet of STM32 board. So suppose just imagine like in our device it was using an STM32 microcontroller. So once we give this particular unique ID in Google in some of the open source, we'll get this data sheets available. And once you get the data sheet, you can look into this pinouts part where like we can find out what kind of point or ports each point is having, because in that particular device we have seen like a square shaped one with multiple pins in on each side. So each of those pin stands for a particular one. Either it can be of ground voltage, and like suppose if it is using a UART protocol, it will have a receiver or transmitter point. So all those things we can find out using this particular data sheet. And once you found out like suppose this is the ground voltage, and all, so you can like mark it like okay, pin number 64 is the ground, like 63 stands for voltage, and so on. So from this you will get an understanding of like what kind of pins it is been using in that particular device. And yeah, I'll go in full screen. Oh. Yeah, so here in the testing point part, we already discussed like suppose if it is using a JTAG protocol, what all pins we have to look into. So now we have seen in that data sheet like various kinds of pinouts. So suppose just imagine like in that data sheet you have found out TDI, TDO, TMS pins. So what does that mean? That means like that particular device is using JTAG. And suppose just imagine like it's not using it doesn't have any TDI TDO ports, and but instead you have found out SDA or SCK. So that means it is using I2C protocol in that particular device. So similarly we'll generally look into these kind of mainly these testing points from actually there are other points as well. We are mainly focusing this because this is pretty much common, and from a beginner's perspective it will be very much like good to know. So we'll look into these points whether that particular data sheet is having any of these points. So that is one like strategy for finding the like pins, like finding the testing points. And another, suppose just imagine like this, in this case we were able to find it out because the data sheet was available online. So okay, it's okay, you can ask me like what if you searched online and you didn't find out any data sheet available. It's not necessary that all the device, like for all the microcontrollers, data sheet will be available online. If it is available online, it is good to have. So if suppose just imagine like it is not available online, then in those scenario, like what we can do is like there is another device called like JTagulator. Nowadays there are like multiple devices coming up in the market, but this JTagulator is kind of uh, open source device. So if you get that, you can, like suppose just imagine like you got this microcontroller and it have various pins over here, and you need to find out, like you don't have the data sheet also, so you need to find out what each of this pin is. So using JTagulator, you can just connect those pins onto the pin where you want to find out what pin is that, and this JTagulator will have an UI interface. So using that UI, you will get to know like that particular pin, what that suppose that pin number 1 stands for what. You will, in that JTagulator's UI, you will get to know like what is those particular point, and and by using that technique you can find out the testing points which is necessary for your security assessment. So these are just the basic ways for finding out the testing points and for understanding the architecture of the uh, like hardware or the IoT device. So moving on to the next topic, like the common vulnerabilities. So now we have discussed about the major components and protocols, and also we have looked into like how to find out the testing points and what should be our approach to understand the architecture and how to perform a security assessment. So now we can look into some of the common vulnerabilities which we can come across in our hardware security assessment. So the most important and the most common one is the firmware extraction via external flash memory. So firmware, actually, we didn't discuss much about the firmware. So majority of the people will be having a basic understanding of firmware. Actually, firmware is nothing but it's a kind of source where it will handle majorly firmware. Depending on the device, it will be either in an it can be inside within the microcontroller. Sometimes it can be in external flash memory. So depending on the device, it will vary. So firmware is a kind of source where it will handle the all the activities, and it will have the various kinds of data related to that particular device. So suppose just imagine like from web application perspective, suppose you are getting a 0-day vulnerability using any injection attacks. So extracting a firmware from an flash memory is kind of similar to that. From the hardware perspective, extraction of firmware, suppose if it is an unencrypted like firmware extraction, then it will go as a high or critical issue for that particular device. So this is very much common uh, vulnerability, where suppose like the a firmware is being stored in an external flash memory, and we need to perform a test case for finding out whether this firmware is extractable. So for that, what we can do is like suppose in your testing from your architecture, you understood like it is having a flash memory. So what you can do is like you can uh, connect the points, like you can take off the flash from the device, from that particular circuit board, and you can attach it to this particular device. So this device is called TNM 5000 universal programmer. So the recent, I think the 7000 series is also available. So in this device you can see this part, right? So that flash actually by desoldering, you can take off the flash and you can attach it to this part, and you can connect this hardware device to your laptop using this particular UI. So this is the UI of the TNM programmer. So using that UI and this hardware, you can try to find out the data that is been there in this particular flash memory. So the process is simple. Like you need to take off the flash and how to attach it to this TNM hardware device, and how to connect it to the UI using your laptop. So suppose your if your device is unencrypted, so you will get in this data in a form like a readable format. So here actually in this case, for your reference, what I have added, it's kind of encrypted data. So when we analyze that particular flash memory, whatever data was inside it, we were able to dump the data, but the data was encrypted. So that's why it's like in this form. Suppose if it is unencrypted, we'll get little more clear data. But in certain cases, even though we get the data extracted in an unencrypted sorry in encrypted format, still if it is weakly encrypted, again we can try to reverse engineer that particular uh, firmware or the data what you got, and you can try to find out other data. So that will be, I have some screenshots for you, I'll show you at the end of the session. So moving on to the next common vulnerability is the unencrypted firmware package. Yeah, so that's what I mentioned. Like firmware extraction can happen, but in majority of the cases, firmware and extraction, what we extracted might be in the form of like an encrypted form. But suppose just imagine like firmware what you extracted is of unencrypted, or not. Just imagine like you're doing a firmware analysis and you found out that firmware is unencrypted. So generally, for reverse engineering the firmware, the common tool what people generally use is a binvoke. And nowadays, like some other tools are also being used, but binvoke is pretty much common and known to most of the security people. So I have kept that as the reference here. So in this example, just here, actually, I think the screen is visible. So actually here it's a command line like binvoke is extracting a particular bin file. So this is the firmware file. On extracting that using binvoke, we found out something interesting. Like here you can see something called squashfs file system. So squashfs file system is something pretty much like critical from the Linux. It's actually a Linux file system. So extracting those file system from firmware is kind of a critical issue, because those file system will have the root access or the root directories. So here also we have extracted the squashfs root file directory. So this all happened from that particular firmware of the device. So yeah, so this happened because the firmware package is not properly encrypted. So this is also kind of a critical issue from the hardware or IoT perspective. And another one is the missing authentication. And here you can see a USB to TTL device. So this device is generally used for performing the test case of UART. If you remember, like we have discussed about the UART protocol, which have the transmitter and receiver points. So this missing authentication part, the example what I have given is like, suppose just imagine like the device what you're testing is having a UART port, or it's using a UART protocol. And so what all like testing points we need to find out? We have to mark the receiver and the transmitter. So the receiver of the UART point will be connected this to this particular device, this TTL converter. So here you can see some pinouts. So this will also have a receiver and transmitter. So how similarly the UART will communicate with the device? We'll connect the receiver of this device to the transmitter of the UART, and in the vice versa, the receiver and the transmitter and the receiver. So we'll connect and we'll use a UI tool called Teraterm for analyzing or like finding out the data communication. So on connecting it properly to the Teraterm tool, we can find out what kind of data communication is going through that UART protocol or the UART ports. So through that, what kind of data is received and transmitted. So here in this particular one, this missing authentication is happening because there was no authentication happened, and we were able to get the root directory or root shell access of the particular device using this by extracting the data from the UART points. So this is also one of the critical issue in IoT security. And another one, and the most common one, which might be familiar to you guys as well, is the use of default credential. For the session, we also have taken a router. So generally, you guys will be familiar. Like suppose if we take a router for the initial router setup for the initial time, the username and password will be of default. The password might be admin123 or admin, and even in cases like username can be admin and password can be admin, or something pretty much common, dictionary based passwords and usernames. So in majority of the cases, people are least bothered to change it, and same happens for other devices as well. Like here also I have attached a router where in certain cases the username and password is directly mentioned. So this kind of usage of default credentials or exposure of default credentials is also one of the common issues which we should avoid from the hardware perspective, hardware security perspective. Yeah, so those were some of the common attack scenarios, and here I have listed the uh, IoT top 10, like from the OWASP 2018. So similarly for web and mobile, for IoT also there is top 10 like security issues which has been updated in the OWASP web pages. So here, like most of them falls under the category where what we have discussed, like the most common one is weak or guessable or hard-coded password, what we have just discussed, and followed by insecure network protocol or insecure access interface. So these are some of the common like vulnerabilities which we come across in like IoT from the IoT security perspective. So if you guys want to look further, you can just Google the OWASP IoT top 10 and you'll get the detailed view of all these 10 attacks. Yeah, so for the demonstration part, I have like added some screenshots of firmware analysis. So because since it is kind of a virtual, as I mentioned, we have certain limitations. So I have attached some screenshots. So we'll be analyzing some firmware because in hardware perspective, as we mentioned, extraction of firmware is one of the most common vulnerability what we come across. And just extraction of firmware doesn't make any sense. Like we have to fetch out something creative or informative to the user or to the public, so then only it will make go as a higher issue. So suppose just imagine like we have extracted a firmware and we don't know whether it is unencrypted. So just imagine like if it is encrypted also, we can still perform our firmware analysis and find out whether it is weakly encrypted or not. So I have attached some screenshots of firmware analysis. So here I have taken a firmware and that it's an image file. So on like extracting that firmware using binvoke tool, again similar to what we have seen before, here also that squashfs file system, that Linux file system is getting exposed. So we'll look into it like yeah, we can also perform one more check like the entropy check. This is the command for that, binvoke hyphen caps e and the file name, then you will get an entropy graph like this. So generally if it is properly encrypted, it will be in a single straight line, but here at the end you can see that entropy is dropping. That means it is kind of that encryption is not proper. So on so here you can see like falling entropy. So on further analyzing that particular image, we can see uh, Linux system is getting exposed. Like over here, from that particular image, we were able to get a Linux directory, and within that directory, on analyzing, we can find like the squashfs root file directory. So for analyzing, depending on the device, you will have various kinds of commands. If you're using binvoke, like most of the commands you can get it from Google itself. So based on that, like we can fetch out this squashfs root directory, and on further digging inside the directory, yeah, we got the like root directories and other user directories and so on. So this is a kind of a critical issue what we come across in hardware security. So this is just like a firmware analysis. Like suppose if you're able to fetch out a firmware initially from the hardware perspective, like if the device is properly secured, then the firmware extraction itself might be of difficult task. But if at all, if you're able to extract, this is the methodology what we follow for reverse engineering the particular firmware. Yeah, so that's all from my end for the session. And yeah, I think we have still few minutes more and it's open for Q&A. If you guys have any kind of questions, I'm open for that.
Hello.
Yeah.
Yeah, I'm having a query. See,
Okay.
I'm having a smart meter and smart technology. In that one, we are having a STM32 controller, and on top of that, firmware is there.
Uh,
So,
actually, I'm sorry, like your voice is breaking for me. Uh, I didn't get
am
you.
I audible now?
Yeah, you're audible, but your voice is
Am I audible
breaking.
now?
Yeah, yeah, you're audible.
Now, now,
Yeah, yeah. Can you please go ahead? Because in between your voice is breaking.
okay. I will repeat my question. I'm
Okay,
having a smart meter, okay, it's a kind of hardware. And in that one, STM32 is the controller. On
okay,
top of that, I'm having some board and that functionality firmware is there. Okay. So
okay.
now I want to check whether STM32 also having the see, in the sheet they will mention this kind of trust zone is enabled and all those parameters, right? So now what I want to do is whether those are really enabled or not. We need to test that FCTA also, right? So in that case, how we will do the hardware test? Are we going to do STM32 or else whatever the firmware we are testing, that only we are doing? Because this question is based on the zero trust architecture I'm asking.
Yeah, actually, again, your in between your voice were cracking, but from what I understood, like your question is like, suppose the device what you're testing is using an STM32 board, and it's having some firmware extraction kind, and you mean what kind of testing mechanism is followed in that case? Is that your
Yes.
question?
I'm asking chip wise also we need to do that.
Yeah, yeah. So suppose if that device is using STM32 chipset, and suppose if it is having any external peripherals like flash or any other kind of interesting components, we can perform those test cases. And also, like as we mentioned, suppose from that STM32 you are finding out like what kind of protocols it is using, then that protocol based security test cases you can perform. Suppose here in today's session we just looked into the UART, uh, UART only, but suppose like if it is using any SPI protocol or a JTAG
I2C or
protocol,
SP2.
yeah, I2C or JTAG. So based on those testing points, we'll use different devices. Like if it is I2C, we have something called as logical analyzer. That's a hardware device. So using logical analyzer will have a similar UI interface. So you can find out the testing points, and by using logical analyzer you can try to find like what kind of data communication is happening in that particular I2C, and whether any sensitive data is getting disclosed. So for I2C's perspective, logical analyzer is being commonly used, and there is a UI called logic itself. So we can perform that attack in that case. So it's actually first if we find out the protocol, sorry, if we understand the like microcontroller it's been used, then another strategy like our task is to find out the protocols it is used. So in your case, since it is using I2C, you can go ahead with the logical analyzer. So in today's session we didn't discuss much regarding that because of the time constraint, so we only focused on the UART part. So yeah, for depending on the protocol there are different security test strategies to be followed.
Hi,
I got a
Anand. Uh, like
Thank you.
Yeah,
Anand,
thank
I have a question. Like we do the penetration testing in for the web application or the mobile applications with the use of Bob Suite or the Kali or Metasploit.
you. Okay.
Can we use those tools in IoT, or there are certain different tools in IoT? And if there is any, and are we going to have any sessions for having some real hands-on? Uh,
Uh, yeah, actually, from the IoT perspective, there are different tools. From the previous attendees question, as we discussed, like depending on the protocol, we'll have different security test cases, and for each security test case, we'll be using different tools. Like suppose if it is using JTAG, the hardware device and the UI interface, what we use is different. For UART, what we use is different. So from the web perspective, with like common tools like burp suite and metasploit we'll be able to perform, but from hardware case it is kind of bit different. Like we have to rely on different tools tools and hardwares. So yeah, that is there. And uh, yeah, regarding the further sessions, I'm not like aware about that. Like the I think the like organizers will update you guys regarding that. Obviously there will be further sessions by following this, but I'm not sure about like what is the topics and all. So yeah, organizers will get back to you on that. But yeah, like from your question, like there is different kinds of tools being used, and we cannot say any common tool, because if it is just for firmware analyzing part, we can say like we'll use binvoke or other kind of tools for reverse engineering. But for the proper hardware pen testing, we rely on different sets of tools based on the protocol that's been used in the device.
Thank you, Anand.
I got a question, it's a quick one.
Yeah,
So, what I mean, the today's session. I mean, you did mention about how to do a security assessment. Uh, if you go in hospital to do a security assessment of 100 of medical devices, of course
yeah,
we are not opening the boards. So what tools? I mean, how do we do it? Will you going to have a session how to do a security assessment of medical devices? Because today's session is more like in depth how to open a board and look at the various
yeah,
components within the PCB. And a lot of people here, I mean, I work with the people who got different backgrounds. So people with
yeah.
security consultants definitely don't understand the PCBs.
Yeah, correct, correct. So the major basic agenda of today's, like, since it is the initial session, we just want our attendees to get a basic understanding of the like security assessment flow and what's the process and components gets involved. So in the further sessions, like as you mentioned, like how to analyze the like medical devices which is in within a healthcare or hospital premise, how to perform those. Like we'll have sessions on that, and like the people will be updating you on that. So just like we didn't touch much onto that, because like this is basically just an introductory part just for kickstarting our like session. So that's why, like, yeah, there is other kind of strategies which been followed for like testing. But in majority of the cases in healthcare devices also, like even though hundreds of devices are used, like before those device goes to the end user, like there will be certain end-to-end security checks will be done like by disassembling and like performing various kinds of checks. And even post, like after applying that in the hospital premises also, like there is kind of tools being used for monitoring, like the protocols so on what is being used, like especially if it is using any DICOM like communications and all, there are certain tools for monitoring and analyzing that. But from the hardware perspective, like before the device going into the end user itself, we'll be performing those kind of checks.
Thank you.
Yeah.
Hi, my question
Hello.
is related to firmware reverse engineering.
Okay.
So, as per I have researched, the firmware can be in a Linux kernel or can be in a RTOS. So, I wanted to ask from both of the perspectives. So, once if the firmware, the Linux kernel is in .lmp file format and it is encrypted. So, in Binvoke, if it is showing that it is encrypted or doesn't show any file system, and if we use emba or some other tool, so if it was able to decrypt the file system in a layman format and I can only see few files, then what else I can do to decrypt the whole firmware and get more out of the firmware?
Yeah, that's actually an interesting question. Like, yeah, actually, firmware reverse engineering, it's kind of a huge topic, and yeah, actually, we just looked into like very basic, like the using Binvoke, and nowadays Binvoke itself, like we cannot say like Binvoke is 100% sure, because
Yes.
yeah, in certain cases it will also show false positives. So yeah, so in the reverse engineering part, when in the real case scenarios, we won't just rely only on a single tool like Binbook. Will reconfirm with the other alternatives, and that
Mhm.
also depending on the like files what you extract. Like suppose the firmware or the particular source what I like extracted is kind of is uh, encrypted, but it's kind of certain strings, then we can use certain tools like ida or hexdump and so on for finding and analyzing another like further regarding that. So yeah, and the next step also will be based on the kind of output or the from what we get from that like initial extraction. So yeah, as you told, like suppose even in the binvoke after extraction, if it is used showing like encrypted or decrypted, we cannot get to a conclusion like it is properly that's the correct one, but still we can rely on other tools like hex editor, or even we can use strings. Like suppose if you extracted a particular firmware, and by using strings you can find like whether any kind of particular strings is being used there in this but inside that particular firmware file or that lnd file you extracted. So yeah, we have to rely on multiple
And
tools.
what if the medical device is using basic RTOS firmware? Then what attacks can I do on it?
uh atos firmware, like you mean you are able to you have extracted a firmware with that atos one, not the linux based one?
Not the Linux. So if it is just bare minimum functionality, like monitor the SpO2 ratings, and with that's just only two or three functionalities. So they will not put a Linux kernel for that simple stuff and only rely on the RTOS. Then what
Okay.
attacks can I do on it? That
uh
RTOS.
Yeah, actually, I'm not fully aware about that, but I think you can like still rely on these tools like IDA or IDA Pros. Suppose if you have it as a file or something, you can try to reverse engineering those tools, because as compared to Binvoke, IDA and IDA Pros, it performs like we have multiple like further functionalities, much more
Okay.
in-depth functionalities. So I'm not fully aware about the Atos environment part, but
Okay,
like.
and this what if the device, the medical patient monitoring or any other device is
Okay.
for that the company has developed their own chipset. It doesn't rely on any standard microcontroller. So then in that case, I won't find anything over the internet because it's a
Yeah,
proprietary thing by the company.
yeah, that's what in those scenarios like we can rely on this open source tools like jtagulator and all, just for finding out like if you have an understanding of what kind of like chipset it is being used, you can try to find out what each of those points is being used. Like suppose if it is using a 32-bit chipset, like suppose you want to find out the chip 6 or 4, and you can connect those points using this jtagulator device, and that also have a ui which will mention you like what is that particular pin out is, and what like once you find out, like even though it is not like knowing to you, like suppose that pin out is of different name or something, you can still try to find out or research further regarding that. So generally hardware pen testing, it's kind of like very much interesting, and we can try to explore, like just because we follow one methodology in one device, it might not be applicable for the other one. So we have to do some research based on, but we have some basic things like in your case, in this scenario we can try these tools like jtagulator for finding out, even though the data is not available in open source, you can try to
Are there
understand.
any other alternatives for JTagulator because it's not readily available like on all of the internet? So, are there any other alternatives which I can use for JTagulator to gain more out of the chipset?
Yeah, alternatives. Actually, there are some other like there is something called as the exploit box. So that is also, but those I think those are kind of a commercial tool where you have to purchase it. Like even JTagulator hardware device you have to buy, but the UI and everything is of open source. But this exploit box and all also you can use for finding out the pinouts or understanding the chipset. So and some other thing. Like I'm not getting the exact name, but exploit box is also something which you can look into. That is also pretty much common nowadays, but that is not an open source one. It's kind of commercial use.
Okay, thank you. That answers all my questions. Thank
Yeah,
you.
thank you. Yeah.
I have a question, please. How can we start in studying IoT pen testing, hardware device?
You mean how to start studying IoT pen testing?
Yes.
Yeah, actually, in like in either in YouTube or in Google, you can find a lot of resources. But the initial thing, uh, like in hardware case, from the web perspective, we can do it with our laptop. But from hardware perspective, we require some hardware things for the testing, because even in today's session, we mentioned like we have to find out some ports and we have to connect it to some device. But for that connection to those device, you will require soldering and desoldering and all. So from the basic perspective, what you can do is like there are some kind of uh, devices with non vulnerabilities. Those are available in the market, so you can purchase one and you can try to perform those test cases, and also you require the soldering devices. Like since you have to perform soldering, you should learn how to solder the points and how to solder the pinouts and how to connect it to those devices. And so basically you will require a multimeter, soldering rod, and you need a device for testing this. So and once you have these devices, then there are a lot of open source videos available in YouTube and other sources, so you can follow those. And like if you're someone who's stuck and wants to get kickstart in IoT, you can get connect with me in LinkedIn or LinkedIn also. Like I'll also share you some resources which is good for a
Okay,
beginner's perspective.
great. I have another question. What are the uses of other hardware tools like Bus Pirate, Shakra, and Jetagulator? Are they commonly used or just externals or what?
Yeah, actually, these are the commonly used open source tools. Like even what we have looked in today, like in the UART part. I think I can show you. Yeah, so in this part we discussed about this Terraterm tool. So this is one of the common tool that's been used for performing this UART test case. So with this tool we can perform the UART test case, like for finding out what data is going through the UART communication protocol. So similarly for each of the protocol we'll use a different set of tools. Like we cannot use a single tool like in web what we use for hardware. Suppose here in this one we were using this TNM programmer. So depending on what testing device what we use, that particular testing device will have a particular tool for analyzing the data. So this tool is used by this particular TNM programmer, so that's why it's been used. So if suppose for analyzing the flash memory, if you are using any different device, that device will be having a particular UI for analyzing. So, but what I have mentioned in today's session is kind of common tools and devices that is being used in the industry, and these are open source as well.
Great, thank you.
Yeah. Uh, yeah. Any more questions? I think we are already out of time. Yeah. Uh, yeah. I think I cannot hear you fully. It was breaking for me.
I'm not sure why.
Uh, I'm sorry, I'm not able to hear you. Is anybody able to hear her? Uh, I'm sorry, I'm not able to hear you. I'll give you some. Already we are out of time, so I'll give you something. Like I'll have mentioned my LinkedIn handle over here. This is a link, so you can connect with me. I'm pretty much active over there. So if you have any queries or doubts, or if you want to kickstart in IoT security, you can feel free to connect with me, and I can assist you with some resources. And if you have any doubts, also you can feel free to connect with me. I'll be pretty much active over there. So you can connect there, and if you feel free to ping if you have any doubts.